Welcome everyone to today's panel discussion, and the subject is artificial intelligence and sustainability. In a moment I'll introduce the panel and the subject, and after that I'll ask each panel member to open with their perspective, after which we'll open the discussion to the floor. If you'd like to speak, please indicate on the chat. At the end I'll sum up and we'll take a vote on the proposition: is AI a net contributor to or detractor from sustainability? Also, if I could ask people to stay on mute unless they're actually speaking, and if we could have the panel members on video, I think that would be great as well. Introduce the panel members. So today we have Professor Ed Keedwell, who we heard from earlier, who's Professor of Artificial Intelligence at the University of Exeter and a Fellow of the Alan Turing Institute. He has research interests in optimization, machine learning and AI-based simulation, and their application to problems in bioinformatics and engineering, yielding over 160 publications. He leads a research group focusing on applied artificial intelligence and has been involved with successful funding applications totaling over £3.5 million from the EPSRC, Innovate UK, EU and industry. Areas of his current interest are the development of sequence-based hyperheuristics, the optimization of future transportation systems, and human-in-the-loop optimization methods for engineering. We have Loïc Lannelongue, who is finishing a PhD at the University of Cambridge, working at the intersection of AI and biology. In parallel with his research, he has led the development of the Green Algorithms project, which aims at raising awareness about the carbon footprint of computational research across all fields of science through an online calculator. He has published 10 simple rules to make your computing more environmentally sustainable, and recently a blog article in the BCS IT Now about the impact of high-performance computing. Dr. John Panneerselvam is a lecturer in informatics within the School of Informatics, University of Leicester. John largely focuses on energy-efficient data centers, involving predicting the future trend and behaviors of workloads at the data centers, thereby reducing the active server resources. This involves studying large-scale commercial data center trace logs, involving descriptive, predictive, and prescriptive analytics with a range of machine learning and AI techniques. John holds more than 60 peer-reviewed publications. Louise Krug is BT's Application Research Sustainability Technical Lead, where she defines, develops, and drives concepts from research through implementation to deployment. She has been in the forefront of developing BT's major energy model, which helps it understand how, why, and where it uses electricity. This has driven major network changes, leading to energy and carbon reductions. Her research uses physics, engineering, data science, and human behaviors to identify solutions and drive change. Previous research has included 3G mobile agents-based information systems and the development of high-power lasers for transatlantic communication systems. She has published over 40 papers and book chapters. And finally, myself, I'm Andrew Lee, head of AI at a company called Hello Done. I've been an AI practitioner since I left university in the 80s. I'm a member of the BCS Specialist Group for Artificial Intelligence Committee that organises this conference. So, on to the subject. Sustainability is a topical and long-term concern. In 1987, the United Nations defined sustainability as meeting the needs of the present without compromising the ability of future generations to meet their own needs. Many of us would probably go further, include not just people, but other species too. Clearly, climate change is part of sustainability, which some regard as an existential threat, not just to people, but to all other life on this planet. Artificial intelligence is potentially part of the problem and the solution. For example, many CPU and GPU intensive machine learning applications use significant amounts of energy. On the flip side, AI algorithms may help us understand global warming or optimize energy use. In this discussion, we intend to discuss how AI may hinder sustainability and how that may be mitigated. We intend to discuss also how AI may contribute to sustainability and how that may be enhanced. These discussions might range from the technical, looking at different algorithms, through to policy, regulations, and best practice. So, can we now turn to the panel for their perspective on AI and sustainability? And I wonder if Louise would like to begin. Thank you.
Okay, thank you for that. So for those of you who don't know, BT is one of the world's leading communication service provider companies. We serve the needs of customers in the UK and more than 170 countries worldwide with fixed line services, broadband, mobile TV, networked IT and wholesale services. And to provide these services, we use nearly 1% of the UK's electricity supply. That's a huge amount, and so any energy reductions that we can make will help the UK to reduce its carbon footprint and balance the electricity supply, which is itself undergoing huge changes to decarbonise, whilst at the same time scaling up to support the electrification of things like transport and home heating. Sustainability isn't a new topic for us, and we've been explicitly working on it since about 1997. We've reduced our electricity use by 18% over the last 10 years compared to a UK average reduction of only 13%. And that's despite things like rapid traffic growth and the deployment of fibre broadband. And of course, we are on a zero carbon green tariff, although we do still need to reduce our electricity use, as us using green electricity simply means there's less available for others. So I don't know if you picked up in the introduction, but I certainly don't claim to be any kind of AI specialist. I'm a pragmatist, and I focus on what I want to achieve and then use whatever is the best tool to get there. And despite working in a data-driven culture in a team full of AI specialists, me, AI is not the first port of call for solutions. Indeed, when I was first tasked with identifying opportunities for energy saving, I was asked, what do we need to buy? How much will it cost? What's the new technology that's going to help? And it took a surprising amount of effort to convince people that the biggest benefit would come from simply turning things off, specifically legacy networks that had few users for the amount of power they required. Dial IP, for example, was a 56 kilobit per second internet service from the early 1990s that wasn't taken out of action until 2013. I say simply turning things off, and it turns out that can be more complex than you might think. And in fact, the people in our team are using AI techniques to try and work out how best to reconfigure the network to enable equipment to be removed without affecting performance, and to help us train engineers to safely make the necessary changes, as many faults, both physical and software, tend to occur when we alter the network. I do know it's easy to get excited by technology and to spend happy hours tweaking your algorithm to get the best results. And we might also take great care to ensure that any code we write is easy to read, understand, and debug. We are really unlikely to consider how efficient that code might be unless we get bored waiting for it to run. We might decide to run substantially more training to improve the output by a few percent. And running those training sessions uses electricity. Green electricity is a scarce resource. But it's far much more than just the in-use electricity that we need to consider. All those models run on hardware that we might decide to upgrade to make our models run faster. And that hardware uses many valuable resources in its production: electricity to make semiconductors, scarce materials such as copper, which is also associated with human rights issues. And when that hardware gets to the end of life, it joins increasing quantities of electronic waste that is often not disposed of safely, leading to toxic chemicals such as lead and mercury being leached into the soil and contaminating water supplies. The carbon associated with producing hardware is referred to as embodied carbon, and I estimate that the embodied carbon in many electronic devices is equivalent to the carbon emitted by the device over a lifetime of about 8 to 12 years of use. Or in other words, if you replace your GPU every couple of years, there's more carbon emitted in the manufacture of the replacement than is emitted during its use. Sometimes it might just be better to leave your code running all over the weekend. I think also we often prefer to talk about the benefit of AI to help reduce emissions, optimise the use of resources, how the final output of the model might be a very small, simple bit of code that can provide significant benefit to a person or industry. But here again, we do need to be very careful and look at the whole real-world impact. In, I think, 1865, a British economist, William Jevons, described how more efficient steam engines led to increased coal consumption because although each engine used less coal, better engines meant cheaper engines, and that meant the market expanded. So if we optimize transport with AI, do we reduce the emissions and the miles travelled, or do we make it cheaper and easier to travel, which makes it more attractive to travel, and so increase the total miles travelled and the associated emissions? For 20 years or more, people have made claims about how technology can help reduce emissions. And whilst the rate of growth might be slowing, emissions are still rising. That's not to say there's no role for AI, but I do argue that it does need to be proportionate. We shouldn't use a sledgehammer to crack a nut just because it's a shiny, nice sledgehammer that everyone is very excited about. And to that end, I encourage the building of naive baseline models before attempting to do anything more sophisticated, costly. And use those models to ground discussions about how accurate the model needs to be capable of creating real-world benefits, and how much additional effort or complexity it's worth investing to get what could be a potentially small gain in performance. And central to that cost-benefit analysis, we should know the full end-to-end, whole-life environmental costs. It may not be easy to quantify our climate impact, but if we don't quantify it, we are unlikely to be actually reducing it. Thank you.
Thank you very much, Louise. And may I turn now to John?
Thanks, Andrew. Just got some slides to go through, just a couple of them. I hope you can see my screen there.
Yep.
Excellent. Right, so our perspective for sustainability is focused on data center sustainability in the past decade, really. So we started off looking at the energy consumption of data centers. I think this statistic is quite popular there, and very often they are cited when we talk about ICT energy consumption and data center energy consumption. So you could easily see data centers, they consume a staggering amount of, energy every year, accounting for up to 416 terawatt hours each year. I think it was 2020, and it really picked up this year as well. They attribute to about 3% of the global electricity consumption. And one of the important factors that are attributable for this staggering amount of electricity consumption is the presence of zombie servers in the data center. So I'll talk about that zombie server in a minute. So that creates the need for addressing this, the excess energy consumption of these data center. One of the important reasons why we wanted to research this issue is, there are potential areas where we can look at to reduce the energy consumption, particularly if we could identify these zombie servers and try to reduce their presence in any data center. That could possibly help to cut down the input electricity. So some attributes of sustainable data center, for example, the cooling management is obviously, it is inevitable. We'll have to cool down the resources down anyway, the server resources, after we run them for a significant period of time. But the surprising fact is cooling management can easily consume 1/4 of the electricity of the total data center's consumption just for cooling the server resources down. It could be, air conditioning or other, water-based cooling management systems. But one of the options the service providers have is to move the data centers to potential areas where the outside temperature is naturally lower, reducing the requirement for these artificial cooling management systems. For example, Nordic countries, Iceland, Sweden, for example, we have numerous data centers there. But the potential problem is, again, we cannot move all the data centers in the globe towards that Nordic region. So we need other ways of reducing the amount of cooling that we need. And from the perspectives of powering up the data center, recently there's a trend of using renewable sources. For example, Baidu and Alibaba, they are already using wind energy for powering up their data centers. And also I wanted to emphasize on the power usage effectiveness of these data centers as well here. A PUE of 1 implies the data center is very energy efficient, meaning we don't need any additional power for cooling these servers down. A PUE of 2, for example, we need every other unit of power for cooling the server resources down, and the global average is still 1.7. There are initiatives being taken by, for example, Google. They are pushing to reduce the data center towards 1.0 with obviously their artificial intelligence techniques. So our motivation is basically to reduce the input electricity of these data centers by reducing the number of running servers, active servers at any given time. At the same time, as a consequence of that, we also we can also reduce the amount of carbon footprints thrown out to the society, obviously leading to a sustainable green environment. Obviously, there are still a lot of work to do. So I just wanted to present one of the areas that we work in this context. So, for example, here, an important underlying cause that we identified here is over-provisioning of resources. For example, service providers, they wanted to keep up their reputation. They don't want to lose their customers. So, they wanted to provision more resources than actually needed by executing any workload just to satisfy the customers. But in that attempt, they leave most of the resources, the provisioned resources, unutilized. So, for example, here the green peaks are the actual level of resource provisioning, and the dark green ones are the peaks, are the actual usage. So you could see the difference between what is actually being provisioned and what's actually consumed at the data center. So with the machine learning and AI approach, if we could basically predict those the requirements accurately, then possibly we can bring down the level of provisioning down in such a way that the amount of resources unutilized, we can keep down to an absolute minimum. So if we have more unutilized resources, for example, the difference between what's provisioned and what's actually consumed is significant, then we call those as zombie servers, and they can exist in a data center without even being notified for a significant period of time. So on average, most of the resources, they are they're not being utilized. On an average, you could easily think about 90% for these unutilized proportion. So that's one of the objectives. Obviously, we do other analytics as well. For example, to predict the number of workloads, the amount of workloads that we are expecting in any particular time, so that we can scale up or scale down the server resources depending upon what we are expecting in the near future. So then again, that's again in our quest of reducing the number of active servers down. So use only when we need. So obviously the motivation is to make use of these server resources, make a maximum utilization of minimal number of running servers. So again, in the recent years, we have used statistical machine learning and deep learning approaches for developing this framework for predicting the future expected trends of user behaviors and workload behaviors. At the same time, we have also published our descriptive statistics as well, like modeling the server behavior, modeling the user behavior, and so on. So that's one of, that's just a flavor of what we do in this context in the recent years. Obviously, we are still looking at other areas. For example, reducing the number of long tail stragglers is one of our other objectives. So whereby, for example, if some tasks run longer than usual, then they can also attribute to these excess energy consumption. So that's, we focus on a few areas in this context, but just wanted to give a flavor of what we do in this panel. So all of our publications, in this context are available, so you can find them in Google Scholar, and I'll be able to take questions at the end of the session.
Good.
Thank
you very much, John. There's some pretty dramatic figures there, I thought. Loïc, may I turn to you, please?
Yeah, sure. Let me just share my screen. Are you able to see it?
Yes, we can see it.
Brilliant. So yeah, thank you for the invitation. It's great to be here to talk about that, especially in such a great company. So these are tough acts to follow, but I'll do my best. Basically, in the next just 5 minutes, I'll try to discuss, probably not answer, but 2 questions. The first one is green computing easy? Hopefully, I'll show you that it can be. But is green computing easy enough? And I'm not so sure about that part. So I've developed some of these ideas because we don't have much time today in what Andrew mentioned. So just a quick blog article published in IT Now recently before the COP26. So you can check this out if you're interested. But the main point I discuss is it does, like high performance computing in particular, does feel a bit like magic to me sometimes. You know, you can have your tablet or your smartphone and you can train a neural network from that just like that, just by logging in into some sort of cloud computing, you know, dozens of CPUs, unlimited memory. It's just brilliant. And it enabled like incredible discoveries, and it made it a lot easier for a lot of scientists, which is great. But on the flip side, you know, if we just take the example of air pollution, it's around 4.2 million deaths per year, and it affects 91% of the world's population. And despite a lot of progress recently, and as John mentioned, data centers still need a lot of energy to run, and energy projection is a big factor of that. There are lots of numbers, but there's one I quite like, which is that it's the carbon footprint of data centers is somehow similar to the entire American commercial aviation, which I find quite striking. So what does it's not only about energy production, obviously, but where does it come from? Broadly, I think we can divide the environmental impact in three big groups. The first one, and Louise mentioned it earlier, it's the life cycle footprint. It's the cradle to grave, including manufacturing. And if we look at consumer device, so you know your iPhone or your tablet, as much as 80% of their entire carbon footprint is just manufacturing. It's obviously lower for servers because they're used a lot more, but still substantial. Like depending on the lifespan of the hardware, it can be some between 10–20%. So that shows how important it is to like just keep devices for longer. Then we can move to like long-term data storage. Again, depending on data centers, we can be around 10% of the energy bill of a data center can be just dedicated to data storage. So I guess that's a good argument to start cleaning our hard drives at work a bit more often. And finally, the part we all think about when we think about the carbon footprint of AI, it's powering the computers while we actually run the tasks. And that's where it can get quite messy. You know, what to take into account, which type of computers and which computers do we want to look at? And then if we start to dive even deeper, what hardware are we interested in? Which ones are relevant? And what about the electricity? We mentioned that a bit. Does time impact it? Things like that. And each of these small points is a very deep rabbit hole, especially if like sustainability in IT is not your primary field of study. And it can look very time consuming, very complicated. And that's partly why I think not so many people look at it compared to like the number of people doing computational work. It doesn't mean no one's been working on it, obviously, and everyone here shows that. There have been quite a few scientists raising awareness about that, especially around the issues of accessibility and ethics, especially when we think that the populations suffering the most from climate change and from the environmental impact of AI are also the populations who will benefit the least from the latest developments in like Apple's Siri or, you know, Amazon's Alexa. And there's also, you know, the big ethical issues of what happens if all these big language models that are quite important in many aspects of societies are only like sustained by a few companies. I guess Google's made its point by disbanding the ethical team behind the stochastic parrot just after they published it. So, and they made some calculators to estimate carbon footprint dedicated to AI. And I guess we're talking a lot about AI today, and that's the point of it. But that we started to wonder, is it only AI that's responsible for it? And it really isn't. For example, if we look at that, XSEED is a large cluster of supercomputers in America. It's basically a lot of institutions coming together to mutualize resources. And looking at the statistics from last year, 9 billion compute hours were charged. That's 24 million hours every day used to like do computations across all fields of science. I find that number quite mind-blowing, but it just shows that all fields of science with any kind of computational component have some responsibility. So that's what motivated the Green Algorithms project, something we worked on with Jason Greeley from who was until recently at the Baker Institute in Melbourne, and Michael Inouye from Melbourne and Cambridge. So it's just basically a calculator and just raising awareness and making it easy for scientists to calculate their carbon footprint. So I won't talk more about that, but if you're interested, there's a publication. You can all the details are in there. And that takes us to the most important part. What can we do about that? And there's a lot we can do, actually. Some of that have been mentioned already, some of them not, but I would love to spend a lot more time discuss that, but I don't think Andrew will be very happy with me if I do. So I'll just jump straight to the end. And I'll just point you at this like 10 simple rules article we tried to put together that's hopefully very short and very straight to the point. So if you're interested in what you can do about that, just give this a quick read. And what do we still need? Well, we need to make it even easier. And that was the point at the start. It's getting easier. It's not quite there yet. It needs to be easier to estimate your carbon footprint, and all these calculators are here for that, but also easier to reduce it. And to sometimes offset carbon footprints. And the only way to do that really is by being more transparent and having the information. You can only, reduce it if you know, are your algorithms bad, or is the data center so bad that actually you would need to use other resources and maybe not use your institutions? And the only way to do that is to have all the information. So that requires transparency from everyone involved. I guess the main bottlenecks, depending if you're working private, in this case, these are the cloud computing services, which are not always super transparent. Same thing for the institutions. They don't always like to comment on that. And us, just as scientists and using computing, we do need to be more transparent about the impact of our work. It obviously doesn't mean we shouldn't do it, but just acknowledge it as we would with financial cost. So yeah, I'll just take this opportunity to thank everyone involved in this project, and do reach out if you have any questions or comments later on. And I'm looking forward to the discussions.
Excellent. Thank you very much, Loïc. May I turn now to Edward?
Hi, thanks everyone. Yes, tough acts to follow all, so but I'll do my best, and with some apologies for a little bit of overlap with my my presentation this morning. Yeah, I think so. So what I wanted to focus on is these sort of headlines that we've seen recently, particularly around COP26, around the initiatives that the government is putting in place for sustainability practices. So moving towards focusing particularly on technology developments. So the move to renewable energy sources, the transition to low or zero carbon transportation through electric vehicles, etc., and the changes to the way in which we heat our homes and offices, which was very high profile in terms of the move towards heat pumps. And whilst each of those technological developments is welcome, simply replacing a gas boiler with a heat pump or a petrol vehicle with an electric one is only really part of the solution. We do need to think, as the other speakers have said, not just about our CO2 and our energy. I think there's a possible issue that we over rely on that CO2, that carbon issue, and we don't think about all of the other damage that we're doing to the environment. So, for example, the materials required to create all of those individual cars. I don't know, for me, whether it's a solution to go from everybody driving a 2-ton or 1.5-ton, 2-ton box and only having one person in each of those boxes. Whether that's a sustainable solution, whether it's powered by electric or by petrol or diesel, I think is a good question. And I think we need to think about that materials footprint, as I say, as the other panelists have said. And of course, the alternative, which is to sort of introduce a significant reduction in our quality of life through reducing the energy and materials footprint, is something that would be very difficult to achieve, particularly in the West, I think. It'd be very difficult to politically achieve that and to get buy-in from the population, as you might expect. And so we need to think about how we promote that thinking, whether we can just simply replace coal or gas with renewables, a petrol car with an electric one, a gas boiler with a heat pump, business as usual effectively. Whether we can do that, I think, is a big question. And my thought is that we shouldn't. I think we need to think about moving to a more optimized approach, a more efficient approach, and we can use optimization tools, which is my research area. I'll put it out there for full transparency out there as a way to do that. And just as an example, the average home at the moment uses approximately 8 to 10 kilowatt hours of electricity per day. And if we add in everyone in the country having an electric car as well, or every household in an electric car, that's another, and drives it at the average number of miles, just 28 miles, that moves up to, that's another 8.5 kilowatt hours per day that we would need. And then if everybody's using heat pumps, and assuming that they are 100% efficient and that gas is only 85% efficient, we'd require another 28 to 32 kilowatt hours per day for the hot water and for the heating for that. And so that means that if these figures come with a health warning, they're from the internet, but if those figures are roughly right, we need something like 5 times as much energy in the UK as we currently generate, and obviously with most of that being renewable energy, hopefully, okay, or renewable and nuclear, so zero carbon electricity. So that's my sort of illustration of a future where we just do everything the same as we're doing now, but we just replace one technology with another. And I just don't think that's feasible. But then when we factor in aspects like freight transportation, where they're going to be charged electric charging or hydrogen, heavy industry, construction, aviation, marine transport, all of those things, if we put all of those onto electricity as well, then how are we actually going to meet those demands? And so I think it's infeasible to think that we can do this without doing some sort of optimization and some sort of rationalization of the resources that we use when we're for each of the journeys that we make, for the homes we heat, etc. And so I think we need to improve efficiency. There are so many inefficiencies and so much waste that goes on with regard to energy and materials that we need to think about how we can best use that. And that's, again, been reflected by what the other panelists have said so far as well. So just one example might be public transportation. So obviously if that moves to EVs, but if more people use things like car sharing, small buses, and we're able to make use of public transport, and it actually gave a service that met more of the demand of people, was more convenient, then we might move to a situation where, yes, hopefully it would be cheaper, as Louise said, but also more efficient in the sense that we would use far less energy and far less materials to do that. And although I've mentioned optimization quite a few times, I think I ought to say that you can't do the optimization unless you do the data science first to understand how people are using these systems. So we need data science, we need machine learning to understand how these facilities, these energy systems and these transportation systems are used before we can hope to optimize them. So, maybe step one really is understanding, and then step two is the optimization. So I firmly believe, as you can probably tell, that AI is net beneficial to this to the sustainability agenda. I would also just like to say one more thing, I guess, is that we should make sure, or I need to make sure myself, that we don't conflate the use of HPC with AI, totally in that case. There are lots of uses of HPC. I'm just going to pick out, I'm sorry to anybody that has Bitcoins at home, but things like Bitcoin mining, those sorts of things that don't really advance us as a society very much, but consume huge amounts of electricity through GPU and CPU usage. And so I would think we do need to differentiate between sort of useful computation, useful AI, useful computation, which may include AI, and some of these sort of less useful computational uses. But that's it from me. Thank you.
Oh, so thank you, Edward. That was very interesting, especially that last point I particularly agree with. So we've now got about 20 minutes for questions and points from the audience and for responses from the panel. If you'd like to speak or make a point, could you just indicate on the chat and include your name if it's not already visible, please? So no one's popped up just yet, so I'm going to kick off with a question for the panel. Does anyone think that AI can actually help directly tackle some of the big problems, such as better understanding of climate change? Does any of the panel like to pick that one up?
I can come in very briefly, Andrew. So I don't know, it's not my field particularly, but I do know that at the university we're working with the Met Office to do some of that, to understand a little bit better to try and improve predictions, I guess, in terms of predicting the climate change. So I guess there's certainly some case to be made for the fact that AI perhaps can improve our predictions and our prediction accuracies for some of these scenarios that we see. I mean, obviously we all know about the 1.5 degrees, which is probably not going to happen now, 2 degrees centigrade. And I guess being able to predict better means that we'll be able to prepare ourselves better for those sort of consequences that seem, well, certainly at probably 2 degrees are probably inevitable now, aren't they?
Yeah. Okay, thank you. Right. So is everyone's chat function working? So I literally have nobody here who wants to make a point, which is unprecedented. Okay, so in that case, what I'll do, Loïc, you were making some points at the end there, and you were saying that you didn't want to dive into them any further because I wouldn't like the use of time. Would you like to enhance any of those that you were mentioning?
Yeah, sure, I can do that. Just on the point before about use of climate change, if people are interested, I think the Mila Center in Canada published something recently, like a white paper, like a large report with the Canadian government about how can AI support the understanding and the fight against climate change. Can't remember the exact title, but I'm sure people can find it. Well, the easy things we can do, some of them have been mentioned before. There was like, keeping your hardware for longer. I guess at the data centers level, it's just including sustainability as a factor when you decide when to renew hardware, when like for now it's mainly cost or performance, but mainly, when is it not cost efficient anymore to keep your chips or your GPUs. One thing is mainly using optimized code. And I know Louise mentioned it a bit and it sounds a bit obvious, but sometimes when we've been using the same package in our code, or we've been using the same software for a long time, we're a bit reluctant to updating anything because we know if we do, it will break everything and it will take us a week to fix the details. But sometimes we've seen, like, for example, in biology, in like genomic analysis, just updating to one version would like divide the carbon footprint by like 10 and also save a lot of time, but sometimes time's not really a factor if you don't really care about that. So that's the kind of thing that it's worth doing. And it's mainly, in general, it's just including environmental costs in a cost-benefit analysis. Like when we talk with wet lab people who run experiments, none of them would start an experiment with no idea how much it will cost them at the end of the day. They all kind of like put it in a budget and decide how much it will cost. So if we were to do the same thing with the carbon footprint, we could make like better decisions. And again, there are like lots, like Ed was mentioning, useful computations, like a lot of them are just brilliant applications. So it's not to say, oh, it shouldn't be done, not at all, but rather say, okay, we at least know how much it will be before we start. We can make like conscious decisions, or say, oh, is it just running it, one more time overnight on the off chance that we will become state of the art all of a sudden, and just get this 1% more we need to get a paper published. So yeah, I guess that's the main different points. But I think we have some questions, so I don't know if you want to jump on that.
Okay, thank you. So Colin Johnson, you have a question there. Would you like to say it out, please?
Sure, yeah. I wonder if there's a role for some kind of explainability here, systems that don't just explain, there's a lot of work these days about explainable AI. I wonder if there's an expanded role for explainable AI that doesn't just explain the why of the decisions, but also explains the environmental impact of those decisions. If we were used to systems articulating back to us what impact they'd had, would that make us think twice about doing heavy computation very casually?
So Ed, is that one for you?
I'm not sure. I think, thanks, Colin. Really interesting question. So I guess in terms of the, I see you've turned your video off now, but do you mean so the AI system would explain where the environmental impact is within its own algorithm, something like that? Is it sort of self-referential? That's where I'm going roughly. Yeah. I think that's very interesting. I think the certainly. Does that sort of point towards sort of almost profiling of algorithms? So as we do with software engineering, for example. So I know, and we do with algorithms too, but being able to perhaps point to particularly carbon intensive operations within, for example, deep learning or something like that, where you have many layers and many sets of computation.
I'm just imagining a system that, you know, when it reports the results to me, also says, you know, you've now burned down 2 trees in doing this. You know, would that make you think twice? You know, about, you know, it doesn't. You know, the measures we use are very abstract to us in
Right.
a lot of ways.
So does that point to Loïc's tool, perhaps, that we saw an image of?
Yeah, so the trees, we had this question of how to, because, you know, people don't know what a kilogram of CO2 is, especially when it's CO2 equivalent, like people have just no idea. So we used we created like this 3-month measure. We just say, okay, well, it would take that many months for a tree to sequester this carbon. And it's obviously a very rough measurement and there are lots of things going into it, but we found that people really engage with that and it gives people a better idea. So the calculator would be a good idea. And we actually made it, you know, a lot of you probably use Slurm as a system to run compute on like big HPC facilities. It's just a system that, you know, just prioritize jobs. And so we included it in Cambridge. We've been beta testing. If you're interested in that, do get in touch. Just basically, you have the My Balance job, which tells you how many hours you've used and, you know, how many credits you've got on the cluster. And now if you run a slightly different commands, it tells you how much carbon you've how much carbon you've emitted through your jobs and how much. And that's really interesting because it gives much finer details because we have basically all the logs from all the jobs. But it's not quite what you mentioned about having something before you run the jobs, which would be ideal, but it's still like just after you can easily get it. So I think these would be useful, but yeah, it needs to be done by institutions as well, or at least have institutions on board.
Yeah, thank you. So it's almost that we need not just explainability, but accountability within the AI to explain why it's using the energy that's using. And to an earlier point, of course, it's not just AI that's burning it all up. Louise, I don't know, did you want to comment on some of that?
No, I just think it sounds a really good idea. If we could, anything that we can do to make it easier to understand what our impact is, because if you don't understand something, you can't change it. It's always the first step in being able to do anything. And I always wonder whether, you know, we should be looking to go further and whether there should be a lot more, in the same way, certainly within the EU, that, you know, if you buy a fridge, it's got an energy rating on it. Should lots of other things from cloud computing to software packages have simple ratings so that it makes it easy for people to do the right thing?
That's a really good idea, isn't it? Yeah, excellent. Thank you. Dr. Amar, you have a question there. Okay, shall I read it out? Yeah. So his question is there any real applications for merging AI algorithms with any energy consumption to protect the environment? So I don't know if anyone can pick that up.
I can have a go at it, Andrew, if you.
Thank you.
I think there are lots of examples. I can quote some examples, some real world implementation in the data center case. For example, so whenever I talk about modeling the user behavior and the, you know, understanding the workload behavior, that's machine learning. And of course, we will have to implement it somewhere in the data center. So in the data center, the knowledge that we extract out from these machine learning algorithms are directly applied in, for example, schedulers, or when we basically allocate tasks for processing. So the scheduler usually, when we talk about multiple cloud data center providers and scheduling across, multiple data centers, we have a meta scheduler that sits at the top that finds the resources. And in this case, for example, the scheduler and a module perhaps can give us some inference on whether we could basically cut down the service. And for example, to answer questions like where do we schedule these tasks for execution? And recently, there's another area of research emerging, for example, including a cost estimation and also energy estimation before even we think about scheduling these tasks. How about presenting the users the option? As a user, if I submit my workload to the data center, I would possibly don't know how it is actually processed, at least the servers or virtual machines in the data center. So now how about giving the users the control? For example, we can do some cost estimation based on what we learn and give the users the option. For example, option 1, we can get your jobs done as soon as we can, but that is obviously going to cost you more, and also maybe produce more environmental impact and maybe consume more electricity. And option 2 may be environmental friendly, so it may take a while, but we can find some environment saving server resources by consuming less electricity and throwing out possibly less carbon footprints. That's one example in the data center. Obviously, when we talk about other real life examples, whenever we go to book our flight tickets, for example, some say they are environmental friendly. Obviously, there is an attempt there to reduce the amount of carbon footprints that are thrown out to the environment. Obviously, without AI and machine learning, I don't think that's any possible.
So building on that, Ed, do you think AI could be used to help optimize other heavy algorithms or applications? Because we're hearing that AI isn't the only culprit, as it were, in burning all of that cloud computing. Do you think AI itself could be used to actually make those things more efficient in the way in which they work?
I guess so. I think that's interesting. There is this field, sort of search-based software engineering. So looking at using optimization approaches to do limited amounts of programming, and usually those objectives are. I mean, Colin has worked extensively in this field. I haven't, but there is this. The idea is that you use these optimization techniques to develop bits of pieces of code for specific objectives, and I guess we could certainly introduce the carbon footprint of the code, or carbon footprint of running the code, as part of those objectives, so making that as efficient as possible. And I think that kind of points a little bit to a comment just coming from Per Arn in the chat as well, about what we implement our algorithms in, and how we implement them actually has a big effect on how much computation is used. So it's not just the procedure itself, but it's also how it's implemented that's going to determine how much of the resource is used to actually run the thing. So I guess it's sort of incumbent upon us all to try and make that as efficient as possible, and to generate the most efficient formulation that we can. I guess we all try and do that anyway by to reduce the runtime, but perhaps there's more that we could do there.
Yes, maybe so. I do sometimes wonder whether different programming languages actually encourage different amounts of CPU use just in the way that you naturally code them. And sometimes the fact that there's a huge amounts of RAM available means that people don't particularly necessarily think about optimizing their code because they simply don't need to, and the cost of writing the software is perhaps more than the cost of running it.
But it might be possible to use some of those optimization tools, the search-based software engineering tools, perhaps to optimize that. So rather than just it being runtime, maybe we could think about carbon as well as a second objective or third objective.
Absolutely. So Adrian, you made a point in the chat about software design. Would you like to comment on that?
Sure. Yeah, it's a related point about making the best use of software resources, and in the physical environments, there's a lot of discussion about recycling, and maybe the same could be argued for processing as well. So, so if you've already carried out a computation, don't carry it out again. And transfer learning is a sort of case in point, where you use the learning that's already been established and apply it in a different context, in a different domain.
Okay, thank you. Right, okay, so unless anyone else has got another point, in a minute I'll summarise, and then we'll perhaps go to a vote. Unless any of the panel's got any final points they want to make.
I think just one quick comment, Andrew.
Yes.
When we talk about, for example, explainable AI and the impact in the climate change, from the research that we do, we never talked about, or at least researched about, how these machine learning and the implementation of AI would attribute to additional, power consumption. Also, I made a point on moving these data center to, for example, Nordic countries, which is one possible option to utilize natural cooling to reduce the amount of artificial cooling systems. But at the same time, it just gives me a leading point to see what would be the environmental impact of moving these data centers to naturally, for example, Nordic regions. Obviously we still have energy consumption and we still have carbon footprints out, and it would be interesting to see what would be the climate, the impact on the climate change, with these data centers moving to these Nordic regions.
Yeah, absolutely. Thank you. So as
sorry, Andrew.
Yeah.
Sorry, have we got time for one more, or is that?
Yes, absolutely. Yep.
Yeah.
Far away.
I just had a question for Louise, and it's slightly controversial, but I don't. The other thing I had written down, apart from Bitcoin, was film streaming. Right now, I know we all stream films, and I do that as much as anybody else, so I'm not going to say that. But I just wondered, is there a can we think of a future where we might limit, say, the streaming of films, or at least the resolution, perhaps, to try and limit the amount of carbon that's emitted by the network, for example? I mean, I'm thinking specifically maybe on small devices as well. So do you really need a 4K film on your smartphone? Does it really?
I think on small devices, you'll find that, and on slow speed networks, there will be an automatic drop of the quality provided. I did find it really interesting when COVID first hit. A lot of the video providers suddenly started dialing back their default bit rate, because there was concerns that with everybody suddenly moving to work from home, the networks would be overloaded. And so they all started dialing back their video rates quite substantially, just so that they weren't the ones to bring the internet down. And so there is clearly scope to think about how we do video. We also do a lot of things, and certainly for live video, but also to think more carefully about how things can be cached, predictive caching. So, for example, the network power consumption is pretty flat with time, whereas the usage isn't. So there's also things like, can we persuade people to allow users to pre-cache, down, if you pushed EastEnders to people's TVs, then overnight before the program went out, they've got a copy of it there ahead of time, which is what people don't like. But, it does mean that it can be transmitted when there's essentially capacity available for free, if you like. So that there are things that could be done, not just on the bit rate, but also how we manage transmission. And I think it also links into what John was saying about data centers. Moving all your data centers to Nordic countries is great, provided you're not shipping huge quantities of data to those data centers as part of your processing. Think about where that processing occurs, because sometimes it makes a lot more sense to run that processing very local, particularly if it's involving a lot of data. So yeah, there's a lot of things we can think about there.
Thanks.
Yes. Okay, thank you. Richard Ellis, did you want to make a comment? I see you've put a note up on the chat.
No, it's just a note. Just it was a quick Google of actually what are the costs of streaming, which seem to be actually fairly low. Although I certainly appreciate that there's always ways that we can make these things more efficient, and especially I think one thing that came out of all of this was the thing that Louise just mentioned, which is actually making use of dead time and of dead resources. Talking about computing services being budgeted for far more than is actually used. It suggests to me there's a lot there that, if it's just sitting there, could be used relatively efficiently for low priority tasks and things like that. So there must be efficiencies that can be made there.
Absolutely. Okay, well, thank you very much, everyone. So that discussion, as always with these, goes in a different direction to the one you expect it's going to go. So we've heard a great deal about the carbon footprint of AI and of computing, which is really quite staggering, especially the figure, the embedded carbon in computing is equivalent to 10 years of use. Really surprised me. And the data center CO2 footprint is roughly the same as American commercial aviation. And of course, a very good point was made earlier on about those who suffer most from climate change, probably the ones who benefit least from these sorts of technologies and from AI. And that efficiency from optimization could help reduce CO2 emissions. So what would be good now, we're going to vote on this if we can. I think Max is going to set up a couple of breakout rooms for us. So The proposition is AI a net contributor to or detractor from sustainability. So if you think it is, please would you go to the AI as a net contributor to sustainability breakout room. And if you think it isn't, please go to the AI is a detractor from sustainability breakout room. And if we could just remain there for say about 3 minutes until about 43 or until the breakout rooms are closed. And that's just to give Max time to count up and see how many have gone into each room. So it's a bit like Parliament voting in the lobby.
It's a low, there were not many people got as far as the breakout rooms, but of those that did, net contributors 13, net detractors 6. So 2 to 1 in favour of contributors, but not all that many votes. A lot of people obviously stayed exactly where they were. How to get into a breakout room, because obviously we wouldn't expect information technologists to be able to do this. It's complicated.
Yeah,
15 to 6.
I was working on the future's bright, the future's orange, or whatever. That in the long term, it will be a net detractor, but in the short term, until all the energy levels get balanced out, it'll probably be, it'll waste a lot of energy.
Yeah. So the future is very much undefined, isn't it? It's the decisions that will be made. So I guess AI could actually wind up being either a benefit or a detractor. So I think with that, we come to the end of our panel session. So thank you everyone for joining us, especially thank you to Louise, John, Loïc and Edward for your contributions and your presentations.